More enticing than any previous case, a late revelation has caused a critical divide between specialists as they now thoroughly examine the data. The expected image of lucidity has acted as the well-known astrophysicist Neil deGrasse Tyson uncovers the dazzling space disclosures. Join us as we research how Pioneer 1 recognized 500 dark objects traversing space and discover Tyson's contemplations on this remarkable revelation. On June 30, 1980, Earth was hit by a stony space rock striking a city in Siberia, Russia. The solid impact of this event brought about the evening of approximately 2,000 square kilometers. The event's significance level worldwide, resulting in an overall shockwave, incited the publication of the Cosmological and Historical Union, Neil deGrasse Tyson's Military, where he emphasized the combination of sensible investigation and public safety, advocating for extended interest in space examination to safeguard our planet. This extraordinary work changed public awareness of the importance of space examination in a confounding manner of events. NASA's space device, Voyager 1, has just identified 500 dark objects passing by in space, leaving analysts perplexed. Neil deGrasse Tyson, the extraordinarily well-known astrophysicist, has once again emerged to provide truly fundamental clarity. However, as analysts delved into the mystery of these 500 unidentified objects, they unintentionally discovered a stunning revelation about Voyager 1 itself. But prior to looking into that revelation, we should first familiarize ourselves with the Pioneer 1 rocket. The daring space trailblazer, Voyager 1, has already traveled an astounding 14.5 billion miles from Earth. The speed at which the rocket travels through space is truly baffling, covering a distance about 3.6 times as much as the space between the Earth and the Sun every year. However, there's another side to the interstellar test that goes beyond speed, life expectancy, and distance from Earth. Voyager 1 has sent a number of Earth-shattering revelations to us, like the recently discovered 500 dark objects in space. These are strange, sublime items that we've never seen or recognized before. We'll get into that massive uncover in just a moment. Nevertheless, there's a question that is likely on your mind immediately right now. How could a rocket launched way back in 1977 still be working and effectively delivering such significant data? The amazing planning is the answer, as well as the intuition that was used in Voyager 1's design. One of the key special features that have extended its lifespan is its double redundant computer systems. Every Voyager rocket, including Voyager 1, was equipped with two command sets, computer subsystems, the Flight Data Subsystem FDS, and the Attitude and Articulation Control Subsystem AACS. This clear redundancy acts as a crucial safeguard, allowing for predictable advances among systems and the ability to institute dormant computer parts, thus extending their life expectancy. The Voyager 1's computer systems and its twin, Voyager 2, were designed as a structure with three double, distributed redundant arrangements of laptops. This redundancy ensured that even if one system failed, the other could win, preventing essential failures. To use limited power sources, the Voyager instruments relied on designed logic. This means that the computer systems were designed with balanced configuration circuits to ensure they could operate within the power budgets and time limits during the rocket's mission. Yet, power management is critical in maintaining Voyager 1's functional integrity. How far away the rocket is from the Sun, where it can harness solar energy, poses a significant obstacle for maximizing power efficiency. Engineers required coming up with novel strategies to reduce the amount of energy used and increase power management techniques used by this critical spacecraft really stand out. One fundamental aspect of power management includes specifically shutting down essential systems. Engineers pay close attention to determine which subsystems or parts are not essential to the primary objectives. For instance, heaters related to certain scientific instruments have been deactivated. These heaters were originally designed to maintain the instruments at specific temperatures for optimized performance. By disabling them, power consumption is significantly reduced, thereby extending the average lifespan of a spacecraft. This decision to shut down unnecessary systems is not an easy task because it requires a careful evaluation of the trade-offs between power conservation and the scientific goals of the mission. Engineers work closely with scientists to ensure that deactivating specific systems does not reduce the quality and availability of scientific data. The objective is to strike a balance that maximizes power efficiency while maintaining essential functionality. However, that's not all. Voyager 1's power management systems also adjust to the changing conditions of its environment. As the spacecraft ventures farther from the Sun, the available solar energy reduces. To make up for this, Voyager 1 adjusts its power usage accordingly. This adaptive approach ensures that available power resources are efficiently allocated to support vital operations and data transmission over continuous years. There have been improvements and advancements in technology in power management methods, allowing engineers to refine and further develop the power systems of the Voyager probes. These enhancements include more efficient power distribution, improved battery charging methods, and changes in how power is controlled. Through these careful power management systems, engineers have successfully extended Voyager 1's operational life expectancy, enabling it to continue its scientific journey through the universe. Considering that the spacecraft was originally expected to last only 5 years, the fact that it's still transmitting data nearly 50 years later is nothing short of extraordinary. It highlights the dedication and expertise of the scientists and engineers who have worked hard to keep Voyager 1 running and functional. But even with this meticulously designed plan, the depths of deep space remain unpredictable. Stay tuned because a critical disclosure is coming. What did Voyager 1 find? What did Voyager 1 track down that shocked analysts? While there are some broad assumptions for what Voyager could have first encountered meteorites in space. There are always rocks and debris in space, and the possibility of making unexpected discoveries is one of the remarkable aspects of the Voyager missions. The spacecraft's detection was the primary mission. This is one of 500 mysterious objects. Everything was altered by this revelation, which caused a stir and raised significant concerns. One of the mission management analysts noted the strange signals and occurrences in the information, which was completely unexpected. Voyager 1 started sending data to telemetry back to Earth, but the readings were strange, and there was no definitive explanation for what was going on. Experts labeled this quirk a mystery. However, despite a few erroneous transmissions, Voyager 1 continued to respond to commands from Mission Control, albeit with a slight delay in communication. This was a baffling situation, and it became a mystery, especially because the anomaly didn't trigger Voyager 1's built-in systems for fault protection. These systems are intended to activate when an irregularity occurs, placing the spacecraft into a testing mode that allows engineers to investigate and evaluate the problem. In this instance, however, Voyager 1 continued to conduct business without entering test mode. After a thorough examination, the source of the anomaly was found to be the Attitude and Articulation Control Subsystem AACS. The AACS plays a crucial role in orienting the spacecraft and controlling its movements. It took a radio signal 20 minutes to travel one way between Voyager 1 and Earth. This substantial time delay presents obstacles to regular communication and command execution. Despite these difficulties, the mission team successfully implemented a fix to send data from telemetry to the working onboard computer. However, the process was not without its complexities, given the vast distance between Voyager 1 and Earth. Even basic communication instructions took time to reach the spacecraft, and the response time was significant. Despite the delay, the solution was eventually executed, and telemetry data began flowing in the right direction, providing clearer and more accurate data about the surrounding space environment. With the anomaly resolved, Voyager 1's analysis could now be the focus of researchers. As experts investigated the telemetry data, they came up with an unexpected revelation. One of the 500 unknown objects detected by Voyager 1 was part of a subset of objects displaying highly unusual characteristics. These objects showed erratic motions, irregular shapes, and unique spectral signatures unlike any other known astronomical phenomena. Initially dismissed as instrumentation errors or noise, further examination revealed regular occurrences in the behavior of these strange objects, which seemed to defy gravity and challenge conventional explanations of existing models of celestial mechanics. The nature and origin of these enigmatic objects perplexed researchers. The discovery of these mysterious objects sparked intense debate and speculation. Some members of the scientific community proposed bold theories, including extraterrestrial intelligence or advanced propulsion systems, while others maintained a more skeptical stance, advocating for conventional explanations. In light of these discoveries, Neil deGrasse Tyson weighed in on the significance of Voyager's findings in a series of interviews and public statements. Tyson emphasized the importance of preserving scientific rigor and care when investigating the unknown. He advised against jumping to premature conclusions and encouraged scientists to conduct thorough research before making definitive judgments. Tyson's measured response to the discovery of the mysterious objects helped temper sensationalism and encouraged a cautious approach to scientific inquiry. He emphasized the need for continued observation, data collection, and research to determine the true nature of these enigmatic phenomena. In the months following the initial discovery, researchers around the world mobilized efforts to study the mysterious objects detected by Voyager 1. Telescopes, space observatories, and ground-based instruments were focused on the parts of space where the anomalies were observed, accumulating additional information to complement the spacecraft's observations. Over time, a more complete picture started to emerge as scientists pieced together the puzzle of the mysterious objects. Through thorough examination and collaborative research, they uncovered clues about the objects' origins and behaviors. While numerous questions remain unanswered, each new discovery brings scientists closer to understanding the nature of these astronomical mysteries. As the investigation into the mysterious objects detected by Voyager 1 continues, researchers remain focused on unraveling the secrets of the universe. Their dedication to exploration, discovery, and understanding demonstrates the spirit of human curiosity and inquiry. In the end, the discovery of 500 unidentified objects by Voyager 1 represents a milestone in the history of space exploration. It has challenged our understanding of the universe and opened new avenues for scientific inquiry. By carefully studying these cryptic anomalies, researchers hope to uncover secrets of the universe and broaden our knowledge of its complexity and diversity.